Hello, we have two problems from JEE 2024. So let's begin with the first one. Have continuously differentiable function on neutral from 0 to positive infinity. Have the initial condition, and this limit is equal to 1, and we have to find the function. Now we have options, so it's easy to just go ahead, plug in and check, but that's boring, so let's solve it appropriately. So let's work with this limit. What I'm gonna do is, if we were to plug in x for t, then it's gonna be 0 over 0. So what I can do is I can apply L'Hopital's rule and have limit as t approaches x of 10 times t to the 9th times f of x minus x to the power of 10 times f prime of t over 9 times t to the power of 8. Now, finally, we can actually substitute t for x. It's actually playable now with 0 problems. So, the first part is going to be 10 over 9 times x times f of x minus x squared over 9 f prime of x, and as we know that's equal to 1. Now all we have to do is we have to solve this linear differential equation, which is not particularly difficult to. Let's first divide everything by minus x squared over 9. Do not deal with that. So we will have minus 10 over x times f of x, not minus, plus f prime of x equals negative 9 over x squared. Now we're gonna find the function micro such that its derivative is equal to its product with x. Not x, f of x. Not like f of x itself, but this, you could say it's linear coefficient. Okay, now divide both sides by micro x. And let's differentiate both sides with respect to x. So, in the first one, we will have a natural logarithm of absolute value of a dx is equal to negative 10 times natural logarithm. Now, we're not going to put absolute value here because we're working only on the positive interval. So, absolute value of a dx equals a negative 10, not negative, x to the power of negative 10, and I forgot plus c. How could I? That's horrible, terrible mistake. Actually, I must be killed for that. E to the power of c. Now, because of the absolute value here, micro x equals plus minus x to the power of negative 10 times e to the power of c equals c times x to the power of negative 10. Now, this only implies that c is not equal to 0. It would work, but what about c equals 0? Well, if we were to say that c equals 0, then micro x equals 0, and plugging it in here, this equality always matches, so it's the general form. Now, let's pick some other constant purely because it's useful for integration context, so let's pick another letter for it. Let's call it k, yeah? And it's x to the power of negative 10. Okay, yeah, now we can just plug it in. We can multiply everything by it, and we will have micro prime x times f of x plus micro x f prime of x equals -9 times micro x is going to be k here, and x to the power of -10. That's going to be x to the power of 12 in the denominator. Okay, now this is just the product rule, so we can clump it in together. ddx micro x f of x equals -9k over x to the power of 12. So let's integrate both sides. Have micro x times f of x is equal to the integral. Okay, let's bring out -9k instantly. Minus 9k times the integral of 1 over x12 dx. Let's divide it by micro x. Now micro x is k times x to the power of -10, so f of x equals -9 times x to the power of 10. Now let's integrate this function. We're gonna have minus 11, okay, no, minus 1 over 11 x to the power of 11 plus c. Okay, nice. Now let's multiply this by -9 times x to the power of 10. That'd be 9 over 11x plus, now we can just ignore the 9 and just write c, x to the power of 10. Now we need to find the constants. Recall the initial conditions. When x is equal to 1, the function is supposed to be equal to 2. So c is just 2 minus 9 over 11. So 22 minus 9 is going to be 13 over 11. 9 over 11x plus 13 over 11 x to the power of 10. Now let's find the option like that. I have 9 over 11x for the first term. Here it is. And for the second term we have 13 over 11x to the power of 10. Here it is. We have found it. It's the answer B. Okay, next problem. We have to find what this equals to. Now, let's begin by simplifying this to statements. The handy things about those is it is sum of sine and cosine with the equal argument. So what we can do is, let's review a separate case where it's more general. Sine of alpha plus minus cosine of alpha. Now what we can do is we can divide it by, okay, not divide it, we can multiply it by square root of 2, and then inside we can divide it by square root of 2. And now the thing is, this is literally the sine sum formula, so this is going to be square root of 2 times sine of alpha plus pi over 4. Now again, plus minus, I forgot to include that. Okay, so let's work with this. Here we can essentially replace this and this. We can pull out the square root of 2 outside. And we have sine of a plus pi over 4. And okay, no, it was in a different order. It's minus pi over 4 here. And then here we'll have sine. Okay, let's move this plus sine. Sine of alpha plus pi over 4. No, our alpha is 6x in this case. Now, again, this closely reminds you, most likely, of the sine or cosine sum formula, very well, indeed, as this is essentially just sine of 6x minus pi over 4 plus pi over 2. In other words, it's going to be equal to cosine of 6x minus pi over 4. And that turns this into the cosine formula for difference. So in the end we have a root of 2 times cosine. The difference is going to be 11x over 2 and minus 6x minus pi over 4, and we're closing the brackets. Okay, now let's do some manipulations to this. 2 cosine of okay, minus 6x is going to be minus x over 2 and plus pi over 4. Now if we were to write out this part here, we can use the cosine addition formula again, but now this time in reverse. We're gonna spread this out to multiple functions. Square root of 2 times square root of 2 over 2 cosine of a negative x over 2 plus square root of 2 over 2 sine of negative x over 2. Now let's just recheck I did not mess this up anywhere. That would suck, sincerely. Okay, so we have a sum here. So yeah, difference here, here. Okay, difference. So there's gonna be some. Okay, yes, I did not fuck up anywhere, I think. Good, nice. So this is essentially gonna be square root of 2 over 2 is just another way to write down 1 over square root of 2. So these two will cancel out. Now cosine of minus x over 2 is gonna be just cosine of x over 2. Sine is an odd function, so we can just write down as minus sine of x over 2. We have severely simplified the problem. Now we just need to find the values of cosine of x over 2 and sine of x over 2. Recall how cotangent of x is minus pi over square root of 11. We can do a substitution. We can say t equals cosine of x. And well, since we're working with x that is supposedly has sign that's positive, we can say that sine is square root of 1 minus t squared. So cotangent of x is going to be t over square root of 1 minus t squared equals a negative 5 over root of 11. Now let's square both sides. minus t squared equals minus 25 over 11. Let's multiply both sides by the denominators. We have 11t squared equals, okay, why did you write down the minus sign here? 25 minus 25 t squared. We add 25 t squared to both sides, and multiply both sides by 36. We have here is t squared equals 25 over 46. T equals plus minus 5 over 6. Now recall that x lies in this quadrant, therefore the cosine is negative. So t is less than 0. Let's apply that. T is equal to minus 5 over 6. Now, you would ask me, why did I just spend a bunch of time in finding the cosine of x? Now, thing is, there are two very nice, amazing formulas. Now, cosine squared of x and sine squared of x can be expressed in terms of cosine x over 2, and that would allow us to, well, find them directly. We have this part over here, cosine of x over 2, cosine of x over 2. Now, here we have, wait. Okay, no, I have plus here, and here it's gonna be minus. Okay, so applying this, we can deduce the values of, okay, no, it's like, why did I write x over 2? It's like 2x. It's absolute opposites. So, for this, we can, well, lower x by half. Essentially, cosine squared of x over 2 is going to be 1 plus, now, cosine of x you have is minus 5 over 6, so, and we have to divide by 2. Multiply both the denominator and numerator by 6. We have 6 minus 5 is going to be 1 over 12. Now for sine squared of x over 2, I don't want to use the same formula, we just subtract this from 1. This could be 11 over 12. Okay. Now, let's find cosine and sine themselves. Now, looking at the fact that it lies in this quadrant, after dividing this by 2, it's gonna lie in the very first quadrant, well, a section of it. If we were to draw a circle like that, x would lie in this area. Both the x and sine are positive here, so we can simply assume that cosine of x over 2 is equal to the square root of this, which is going to be 1 over 2 square root of 3. Now, sine of x over 2 is going to be square root of this, which is square root of 11 over 2 root 3. Now, again, coming back to this, this is gonna be simply 1 over 2 root 3 minus root 11 over 2 root 3. So that's gonna be 1 minus root 11 over 2 root 3. Let's say we have an answer like that. Okay, we actually do know it, so I definitely messed up somewhere. Okay, I might know actually. I'm not sure whether I do, but I might know, as a matter of fact. Okay, yeah, I know why. Here, I should have either left a minus sign, or I should have made this to positive. That was my fault. Okay, I'm sorry, chat. It's gonna be 1 plus root 11. So the answer is B. That was embarrassing.